In this lesson, we will learn what are math functions in C language. With that, we will also see some examples. Let us start. If you want to perform mathematical tasks like finding the square root, returning the sine, cosine, tan, or hyperbolic sine, cos, tan, then use the math functions. C language is having a separate header file for the math functions, that is math.h. So if you want to work with the math functions, include math.h in your program, like hash include math.h. Now we will see some popular math functions. With that, we will also learn about its usage with codes. So let us start with the square root. If you want to find the square root of a number, then use the sqrt function in C language. Let's see them one by one. Here is our VS Code. We added all our codes in the Amit project folder. Let us create a new file. Right click, new file. Demo 47. First we will see the sqrt function in C. I'll add the header file and the main function. The sqrt function in C is used to get the square root of a number. First, let us take a number. We will consider it as a double type and we will directly print it. While printing, we will mention the sqrt function. Square root of, for double we have %lf format specifier is %lf. The output will be in the same type. This is your number A and the last one is your sqrt function, and within that we have mentioned the value. So this will find the square root of A, that is square root of 25.0. Now it looks fine. Save. Okay, and to use sqrt we will add the math.h, else there will be an error. Let us run. Go to file, save, right click, run. We ran it and you can see the square root of 25.0 is 5.0. If you want to reduce the number of digits after decimal, you can mention this. Let's say .3lf. I'll save and only 3 digits will be visible. Here it is. Okay, in this way we can work with the square root function to calculate the square root. Now we have 10 more examples. So I'll quickly create files and also mention the comment and these 2 header files which are required. So let's do it. Guys, we have created all the files. Now let us move to the second one, that is the exp method. Here it is. We already added the header files. Let us add the main function. The exp function in C is used to return e raised to the power of a. So let us see. First we will create a variable, double variable 2. So we will find e to the power of 2. Okay, I'll print exp means exponential value. The exponential value of lf, this is the format specifier for double, is equal to lf. Now here we will add a and then the exp in bracket we will add a. This will return e raised to the power of a. Return. I'll go to file, save. We already added the math.h header file, so there won't be any error. Run. Here it is. The exponential value of 2 is 7.38 This means we calculated the value of a raised to the power of 2.0 here. Okay. Now let us see the next example. Cos function in C. This function is used to return the cosine of a. Okay, we will convert the angle from degrees to radians before passing it to the cos function. Let us add the main function. We already added the math.h header file. Now here first we will use hash define. Here I'll tell you the purpose. We will take the value of pi as 3.14159265. So what is the purpose? The hash define is a preprocessor directive used to create symbolic constants. It allows you to define a constant value that can be used throughout your code. So we have defined it here. So later on if we want to use it, we can directly use pi instead of the complete number. Okay. So this is the purpose. And we all know the value of pi is 3.14. So we don't need to write this completely. We will just write pi using the hash define preprocessor. Let us take a variable a, double a is equal to 30.0, and we will also take a res variable. That will be the result. Now let us convert the angle from degrees to radians. So this is the formula. A into pi divided by 180, and in result we will mention the value of cos a. Okay. This a, which is converting the angle from degrees to radians. That's it. Now let us print cosine of 30.0 degrees. We can also write converted to percentage LF radians is equal to percentage LF. After that, mention A and RES. Okay, so we calculated the cosine of A. I'll go to file, save, right click and wait, we missed the return. Okay, go to file, save and right click, run code. Here it is, the cosine of 30 degrees, which is converted to 0.52359 radians is equal to 0.866025. So in this way we can find the cosine. Now let us see the next example. To find the sine function, first we will take hash define like we saw before. Okay, now we can take the code from here because we want sine now. Right click copy, right click paste. The method is similar. I'll change it to 60. The RS variable for the output. Here also we are converting the angle from degrees to radians. So in the sine function we are returning the sine of A. Here we have converted the angle from degrees to radians before passing it to the sine function. Okay. That means here we are converting from degrees to radians and then we have passed it here. Sine of 60 degree converted to radians is equal to ARES. Same. Return. Okay. Now we will get the sine of A, that is the sine of 60 degrees. Right click, run. Here it is. Okay, here the value is 5, not 4. Okay, we will run. We will save and run. So this is the value, exact value. Okay. We should also fix it for the previous program. It is fine here, I guess. And this looks fine. Okay. Here is the output. So we have used the sine function in C to return the sine of A. A was 60 in this case. First we converted the angle from degrees to radians, and then we added that to the sine. Now let us see the next example. Here we will find the tangent of A. The tan function in C expects the angle to be in radians, not degrees. So we will convert the angle from degrees to radians before using the tan function, like we saw before. So I'll take the code from here. Copy, paste. The steps are almost similar. Double value, let us keep it the same. Now we will convert the angle from degrees to radians, that is here, and after that we will use tan. Tangent of or tan of 60 degrees, okay, is equal to, I'll just print the result, save, right click, run. So the tangent of 60 degrees is equal to 1.732051. In this way we can find the tangent of A. Now the next function, acos. The acos function in C returns the arc cosine of A in radians. So we will calculate the arc cosine of A and convert from radians to degrees. Let us see. I'll write the main function. Before that I'll mention the value of pi using hash defined preprocessor. I already discussed that. So let us take this, copy and paste. Now under the main function we will take a double variable A and give it a value and a res variable to get the output. Now let us calculate arc cosine of A and convert from radians to degrees. For that use the resultant variable res, mention acos and within this the value of A. Then to convert it, multiply it by 180 and divide by pi. That is the following value. Okay. I'll print now arc cosine percentage LF is for double is equal to percentage LF degrees because we converted it to degrees. A and the value of res because it is having the output. That's it. Now I'll go to file, save, right click and run. Our output will be in degrees. Here it is, arc cosine of the value is equal to 107.457603 degrees. Okay. In this way we can find the arc cosine. Now the next, arc sine. So let us take the same code. Similarly what we will do, we will convert. We will calculate arc sine of A and convert from radians to degrees. Okay. This is radians. Rest we will keep the same. Here it is calculating A sine A arc sine LF is equal to LF degrees. So the output is in degrees using the A sine. We will return the arc sine of A in radians using this, but in the complete step we are converting from radians to degrees and then printing the degrees because the output will be in res. Save, right click, run. Okay. This is fine now. right click, run. Here is the output. The arc cosine is equal to minus 17.457603 degrees. In this way we can find the arc sine. Now let us see the next, which is atan. I'll take the code from here, copy, and we will find the, and we will return the arc tangent of A in radians, but we will convert the arc tangent of A. We will calculate the arc tangent like this, and then we will convert from radians to degrees. Okay. So here it is, we are calculating. Let us go to file, save, right click, run. Here we have the output. The output is 16.699244 degrees. Okay. Now let us see the next code. The next set includes your hyperbolic. The first one is hyperbolic cos. Using cosh, we will return the hyperbolic cos of A. So I'll write it int main. We don't need the pi in it. First we will take the value double A is equal to 2.5 and an output variable, that is res. Under the output mention the value of A here to return the hyperbolic cos. Mention cosh and then print it. Cosh is equal to percentage LF because we have double here, and after that mention is equal to percentage LF A res. Okay. Return, right click, run. So the output is 6.132289. I'll just change it, cosh. Okay, this looks fine. File, save, right click, run. Now this looks fine. Okay, cos 2.5 is the following. So in this way we can return the hyperbolic cos of A. The next example is sin h, that is hyperbolic sine of A. I'll take the same code. Okay, now we have the value double, the double variable as 2.5, and here we will add sin h to return the hyperbolic sine of A. Here is the res and here we have sin h, that is hyperbolic sine, and we have printed the result. File, save, right click, run. So the output is the following, 6.050204, that is sin h 2.5. So in this way we return the hyperbolic sine of A. Now the last example, hyperbolic tangent. Okay, I'll take the same code, copy, paste. Here we will add tan h for the hyperbolic tangent. The value of A is similar and we will find out tan h. Printed the output, save, right click, run. So it calculated the hyperbolic tangent of 2.5 and displayed the result as 0.986614. So in this way we understood the tan h function also. So guys, we saw what are mathematical functions in C language. To add it in your program, use the header file math.h, and we saw some popular mathematical functions also. We coded and ran 11 of those functions. Thank you for watching the video.